chapter 13, volume, surface area and volumes. Okay, so the first exercise we are going to solve about cuboid and cuboids. Okay, so I'll give the formula first here. So first one is cuboid, another one is cube. So this is length and breadth and height. Okay, so this is cuboid. So cuboid, CSA of cuboid or LSA. Okay, LSA of cuboid equal to 2 bracket L plus B into H. Okay, LSA of cuboid, or you can say area of 4 walls. Okay, or area of 4 walls. Also same only, 2 bracket L plus B into H, same formula only. Again, TSA of cuboid is 2 bracket LB plus BH plus HL square unit. This is square unit, this is square unit. Okay, and area of base is length into breadth. So there's a rectangle one, so we can say L into B. Okay, so that is for the cuboid one. And next one is cube. And before that, I'll give you that volume of cuboid also. Okay, volume of cuboid formula is that we don't use it for this exercise, but we'll use for next exercise. Okay, so exercise 13 point another exercise will do. Okay, so volume of cuboid is L into B into H. You just memorize this also. Okay, again next one cube. So next one is cube. Cube and cuboid, the difference is cuboid, cube means all the sides are equal. Okay, and cuboid means LBH different one, but here means all the sides are same. Okay, everything is same only. So that means we can see here LSA of cube equal lateral surface area equal to 4a square, and TSA of cube is 6a square, and volume of cube is a cube. Okay, cubic unit, and this area means that is square unit. Okay, square unit, and this is the same square unit, SQ unit. Okay, I'm just writing square unit, and this is cubic unit, that's why I'm writing CU unit. Okay, and now we'll start the question. First question of the exercise 13.1. Now see the exercise 13.1. First question: a plastic box 1.5 meter long, 1.25 meter wide, and 65 centimeter deep is to be made. It's open at the top. Ignoring the thickness of the plastic sheet, determine the area of the sheet required for making the box. And the second one, the cost of sheet for it. If the sheet measuring 1 meter cost is rupees 20. So here a plastic box 1.5 meter long, so length is 1.5 meter and breadth is 1.25 meter, and height is given 65 centimeter. So 75 centimeter change to meter, divide by 100, so will come 0.65 meter. Okay, and here we are going to find the area of the sheet, and this is given, it's an open box. Okay, the area open on the top, that means area of sheet equal to, we'll take here area of 4. It's actually for area of this, as here LSA formula can use. Okay, I think you can use area of 4 walls formula. Okay, area of 4 walls plus area of, instead of, I think you can say for instead of 4 walls we can just say here area of 4 side we can take. Okay, I'll just write it here LSA instead of this one. So LSA of cuboid plus area of base. Okay, so LSA of cuboid formula 2 bracket L plus B into H. So area of base is L into B. Okay, so 2 bracket length is 1.5, breadth is 1.25, and height is 0.65. okay, plus L is 1.5 into 1.25. okay, so 2 into 1.5, 1.25, so we can add it, so it will be how much, 2.75. okay, into 0.65. okay, plus multiply this one 1.5 into 1.25, so it will be 1.875. okay, so now 2 into 2.75 into 0.75 will multiply. okay, so 2 into 2.75 will be 5.5, okay, into 0.65 plus 1.875, so 5.5 into 0.65. okay, so 0.65 will be 3.575. okay, 3.575 plus 1.875. so we'll add these two numbers now. So it will be 5.45. yeah, zeros is no need, so just write here meter square. okay, and the second one, the total cost of the sheet. So second one, we have to find out the total cost, the cost of the sheet. okay, so the cost of sheet for 1 meter square is rupees 20. so therefore the cost of sheet for 5.45 meter square is, we can just multiply 5.45 into 20. okay, 20 rupees, so therefore rupees, so multiply will be 109 rupees. okay, now we'll go to next question. Question number 2. The length, breadth and height of the room are given 543. Find the cost of whitewashing the walls of the room and also ceiling at the rate of rupees 7.5. so we'll use the same formula last question, because the area of 4 walls will use same 2 bracket L plus B into H, and ceiling will be L into B. so same formula last question 1. so L is there, B is there, H is there, so we'll do the same process and we'll try. okay, so length is 5 meter, breadth is 4 meter, H is 3 meter. okay, so area of 4 walls plus area of ceiling. okay, so area of 4 walls formula 2 bracket L plus B into H, and area of ceiling is L into B. so 2 bracket length is 5 plus breadth is 4, height is 3, again 5 into 4. okay, so 2 bracket 5 plus 4 is 9 into 3 plus 5 4s are 20. so 9 3s are 27, 27 into 54, 54 plus 20, so answer is 74 meters square. okay, and same like last question, we'll do the same. The cost of for 1 meter square is 7.50. then we will multiply 74. so therefore the cost of whitewashing the walls and ceiling equal to, you write here straightly 7.50 given in the question, into we got answer 74. okay, so if you multiply these two, we'll get answer. so the answer is 555 rupees. okay, so 555 rupees. okay, now we'll go to question number 3. Question number 3 was given the floor of a rectangular hall as perimeter 250 meter. If the cost of the painting the 4 walls at the rate rupees 10 per meter square is 15,000, find the height of the hall. okay, so here the perimeter of the hall is 250 meter. so perimeter of hall is given 250 meter. okay, perimeter of the hall means the perimeter of rectangle formula 2 bracket L plus B equal to 250. okay, and the cost of painting the 4 walls at the rate rupees 10 per meter square is 15,000. so we can write here area of 4 walls equal to total cost by rate per meter square. okay, so area of 4 walls formula 2 bracket L plus B into H. total cost is given 15,000 divided by 10 rupees. okay, so 2 bracket L plus B we know is given 250 meter, so we can write here 250 here, and here 0 0 cancel. okay, so I'll write it here, 2 bracket L plus B is 250 we got, just write it, into H we are going to find out So it will be here only 1500. So h equal to 1500 divided by 250 meter. So h equal to cancel 0 0, 25 how much is in 150, 25 6. So therefore the height of the hole, okay, height of the hole equal to 6 meter. Okay, so that question number 3 over. Now we'll go to question number 4. So question number 4, the paint in a certain container is sufficient to paint an area equal to 9.375 meters square. How many bricks of dimension 22.5 centimeter, 10 centimeter, 7.5 centimeter can be painted out of this container? So here we'll just take the bricks one first. Okay, bricks one, L is given 22.5 centimeter and B is given 10 centimeter and H is given 7.5 centimeter. So we'll find first TSA, 2 bracket LB plus BH plus HR. Okay, so 2 bracket length is 22.5 into 10 plus 10 into 7.5 plus 7.5 into 22.5. Okay, so 2 into 22.5 into 10 is 225. Point is cancelled. Again 10 into 7.5 is 75. Point is cancelled. Okay, and 7.5 into 22.5, so 168.75. okay, so if you added this one, 225 plus 25 is 75 is 300, so 468.75. okay, this is centimeter, so we're writing centimeter square. Okay, so if you multiply, will be here how much? 93750. okay, centimeter square. So here centimeter square will change to meter. Okay, so divide by 10,000. okay, so now we are going to find how many bricks. Okay, so number of bricks equal to area of the container by area of one brick that we got just now. So area of container already given in the question, 9.375 meters square, and area of one brick we got now 937.50 divided by 10,000 meters square. Okay, so this meter square we can cancel it, and now this one, see, 9375, this take reciprocal, will go 10,000 upside, divide by 937.50. this is same only, and multiply 10,000, see 1 2 3, so 30 cancel, 10 left, so 93750 by again 93750. We'll write, cancelling this 2 point, we'll write upside 100. okay, so now we'll cancel these two, so answer is 100 bricks. okay, so number of bricks is 100. Next, question number 5. Question number 5 is given, a cubical box has edge is 10 centimeter and cuboidal box is 12.5, 10 and width 8 centimeter. Which box has the greater lateral surface area and by how much, and which box has the smaller TSA and by how much? Okay, so we'll find out the cube one first. So cube, the A is given 10 centimeter, so LSA will find out, LSA of cube is 4A square, so 4 into 10 square, so 4 into 100, so answer is 400 centimeter square. Again TSA also will find out, TSA of cube is 6A square, so 6 into 10 square, so 6 into 100, so 600 centimeter square. okay, and next one is cuboid. Cuboid we'll find out here, what's given here, L is 12.5 and B is 10 centimeter and H is given 8 centimeter. So we'll find out LSA and TSA of cuboid. So LSA equal to 2 bracket L plus B into H. So 2 into L is 12.5, B is 10, H is 8. okay, So 2 into 12 plus 10 is 22. 22.5 into 8. Okay. So 2 into 22.5 is 45. 45 into 8 is 8 5 is 40 minus 4, 8 4 is 22, 36. So 360 centimeters square. Again TSA, 2 bracket LB plus BH plus HL. So 2 bracket length is 12.5 into 10, again 10 into 8 plus 8 into 12.5. Okay, so 2 into 12.5 into 10 is 125. This is 80. Okay, so 8 4 is 40, remain 4, 16 minus 2, so 10. So answer will be 100. Okay, so will be 2 into, so 180, 100 plus 80, 180, so 280, 305. So if you multiply 610 centimeters square. So we got LSA of cube is 400 and LSA of cuboid is 360 and LSA of cube is 600 and here is 610. Okay, so now, so the first question, which box has the greater letter surface area and by how much? So which box is there? First one is 400 and this one is 360. So cube box is the greater one. Okay, so we can say cube has the greater LSA. Okay, by 400 minus 360, so 40 centimeters square. Okay, and the second question, which box has the smaller total surface area? So that also same only, cube has the smaller TSA by how much? So 610 minus 600, so will be 10 centimeters square. Okay.